Hello guys, in this video we'll be talking about these three subtopics: heat capacity, specific heat capacity, and latent heat. So we'll see what's the meaning of individual term is, and we'll be also figuring out, let's say, how do we use them to solve like a few relations and a few questions. Okay. So first thing, let's start with the heat capacity. So heat capacity in a way is defined. Let's say you have a substance of any mass m. We are not putting limitation on that. Okay, so it's defined like this: amount of heat you're giving to this given mass, such that the temperature increased, or when you're giving heat, will be increasing, and obviously you extract heat, decrease by one. So amount of heat interaction you need to have such that your given thing will be changed temperature by 1 degree centigrade or Kelvin. Both things are the same. So here I'll take a notation C for this, and C specific your heat capacity would be defined as C is nothing but amount of heat you're giving per unit change in temperature, which is the heat capacity for you. So in here we have Q as a joules in a unit, and delta T you could take it as a degree Kelvin, or this could also be written as degree centigrade. So that'll be your heat capacity. So amount of heat you're giving to change or increase the temperature by 1 degree centigrade. So then specific, the term specific is coming in front of it. So that means we are talking about per unit mass system. So this time we'll be taking 1 kg mass, and we'll be doing the same thing, that you'll be giving a heat to this, and we'll be seeing how much heat you would be needed in order to increase the temperature by 1 degree. So here I'll take a notation S for that. So S will be amount of heat you give to increase temperature by 1 degree, so per unit change in temperature per unit mass. So that'll be your relation for specific heat. So the unit in this particular case would be joules per degree Kelvin, and you got kg. You can also write this thing as degree centigrade by kg. So that'll be the specific heat capacity. So now the third one, which is a little different from these two. So that latent heat come into picture whenever you are changing state, or what you say, phase of a given matter. So let's say you are either melting it, you are either vaporizing it, it will become into play in that. So the term latent here represent in a literal way, it's a hidden heat. So what do you mean by that? When you change state, let's say you have material, and let's say it's going from solid to liquid. So whenever you're giving heat to this particular kind of system, and which is reached at some critical temperature, so that'll be like a melting point for this particular scenario. So it would not change its temperature until it is completely melted away. So because of that, only whenever you're giving heat to the system and it's not changing temperature on it, so we say that okay, there is no significant change in temperature is what you say you're noticing this, that's why you're calling this thing a latent heat. So here the definition is based on that only. So let's take a notation L for this. So latent heat is nothing but amount of heat you give to change any phase from one particular phase to other phase per unit mass. So that will be your latent heat. So in this case your unit will be joules per kg. So in the case of latent heat, you will be coming across multiple names. So it is gonna based on the process it's going through. So I'm just gonna put that there. Let's say you got 3 phases, liquid and your gas, and talk about one by one. So let's say you're going from solid to liquid. So let's this process will be known as a fusion process. So you call this latent heat of fusion. So amount of heat you will be needing to, let's say, melt 1 kg of a solid, that will be latent heat of the fusion. Then next thing you got it as a liquid to gas. So liquid to gas we'll be calling this to vaporization. So latent heat of vaporization you will be coming across in the terms. So then let's go opposite, gas to liquid. So this process will known as condensation. So you'll be dealing with latent heat of condensation. You'll be coming across that. Then you got liquid to solid, so this will be known as freezing. So this you will be calling a latent heat of freezing. Okay, so these are only just the terms used for the describing the process, which process a latent heat constant you have to take. So based on that, you can figure out what will be the latent heat constant you will be using. Okay, so now I'll take an example and explain the whole three things again, and we'll see how that will be drawn as a graphical structure. So right now let's take a ice example. Okay, so ice is going into convert into water, so all three phases, and then it will be converted into steam in a gaseous state. So you got three state of H2O, ice, water, and your steam. So how that will be drawn, and what will be the curve will gonna look like. So let's see. So let's say I'm drawing two axes. On this axis I'm putting Q, that let's say that's a heat you are giving to the system. Okay, so that's your Q, and this is the temperature of the system right now. Okay, so I'm starting with some temperature of ice as T naught. Okay, so let's say this is somewhere T naught we are starting. So now for getting the first relation, you need to understand this. So whenever you increase the temperature of a set system which is not on a critical point, so let's establish your critical points also. So what are the critical points? So these two will be the point where you actually start changing phases. So let's say for the case of ice, that'll be 0 degree centigrade. It'll be converting to water after that. Then you go 100 degree centigrade. That'll be conversion of water to steam. Okay. So I'm just gonna put that points here only. So this is like a 0 degree, and this, let's say, is 100 degree centigrade. All right, so let's make this a little bigger. So first of all, relation which you need to have, I'll be using that very first term that you will be having right there. So I can say that your Q is ms delta T. All right, so delta T could be represented as what do you say, T, your temperature right now, minus initial temperature T naught. So you can clearly see that this is a linear relationship which you got, and the values of M and S will be a constant for a same phase. So if you are in the ice state, your phase will be remaining same. So in that case, you will get a straight line. So your line will go from one particular T naught to a point. So let's say it's going up to here. So after that, once you achieve 0 degree, and phase changes start gonna happen. So the phase change, when it's gonna be happening, your temperature would not change. So because of that, you will get a horizontal line in the temperature because temperature is not changing. So that will be responsible because of the latent heat coming into play. So once you have converted everything into water, you again will increase the water temperature, and this time you would have some different M would be same, but your S will be differing, so you will have different slope curve. So now same thing repeats. Once you have converted everything what do you say, at 100 degrees temperature, you have a critical point again, and there will be boiling point for you. So once it is start boiling, and your temperature will remain as 100 up till you are done with your phase change. So once the phase change is complete, you again increase your temperature, and that's go on like that. All right. So in here, if I have to put across, this will be using what do you say, specific heat to know this principle, like know this heat. So this will be your heat capacity. Whatever temperature changes you are having, total heat capacity would be given by this heat section. Okay, and this will be your latent heat of the material, total latent heat. So latent heat times the mass of the system. Okay, and again this will be heat capacity, and this is latent heat of vaporization, totally latent heat of vaporization, and so on. It goes like that only. So that'll be the relation you should be getting in the case of water. So it is general for every given substance which is going through these phase changes. So whenever you're dealing with the questions on this, you will be coming across a term calorimetry. Let's talk about that too. So it's a very simple concept. The calorimetry is ultimately saying one thing only, that whatever heat is lost by the hot body, okay, so heat lost by the hot body is heat gained by the cold body. So these two things that we have to figure out from the system, that which one is a hot body and it's a cold body, and secondly, how do you find heat lost and heat gain. So heat lost and heat gain would be figuring out by using these formulas only, which you are coming across. So this latent heat you will be finding by using the same expression which we had earlier. So I hope you understood that. In the coming video, I'll take one example also to explain this entire concept one more time. So if you got any suggestion, any doubt, any topic which you want to be covered in those videos, so you can let me know in the comment section. So thanks for watching.